Guys, let's try this problem right here. This question is asking the mean amount of fluid in a bottle of lens cleaner is 59 milliliter. A researcher believes that the mean is different than that. 35 bottles are sampled and the mean is found to be 63 milliliter with a standard deviation of 2.3 milliliter. Test the claim based on this information at alpha is equal to 0.01. Assume it is normally distributed. Now let's go ahead and write our given informations. First, here we have the mean, that is 59 milliliter. Mean is 59 milliliter. And then a researcher believes that the mean is different than that. So the claim here is the researcher believes the mean is different. So different than 59. Okay. And 35 bottles are sampled. Sample number is 35, n is 35, and the mean is found to be 63 milliliter. So x bar here is going to be 63 milliliter, and then with the standard deviation of 2.3 milliliter, so s here is 2.3 milliliter, and then alpha is 0.01. Okay, now let's look at the step right here. First, write down the shortened version of claim, so that's here, different than 59. Come up with the null and alternate hypothesis. See if claim matches H0 or H1. Okay, so first of all, we have to know in null hypothesis, we always have less than or equal to or greater than or equal to or equal to. And in alternate hypothesis, we have less than, greater than, or not equal to. And if you look at this one, they are saying it's different than 59. So we don't know whether it is less than or greater than. It's not mentioned right here. If it's different, it means we know for sure this is not equal to. So this one comes under not equal to, right? So this is, if we put this one H0 and H1, this falls under this H1 because this is not equal to. So we can write that one right here. Mu is not equal to 59. So if this is not equal to 59 in null hypothesis, if alternate hypothesis is this one, null hypothesis is going to be opposite of that because these two are opposite to each other. So whatever come here, it's going to be opposite right here. So for the null hypothesis, we are going to have mu is equal to 59. Okay. Now that is this. Now let's look at the next step. Draw the picture and split alpha into tails. So here they are mentioning the conditions of alternate hypothesis. So in alternate hypothesis, if mu is not equal to value, 2 tails, mu is less than value, left tail, mu is greater than value, right tail. So in our case, we have this alternate hypothesis that is not equal to the value. So this is going to be split into 2 tails. So how it's going to be is, we are going to have this alpha, this is 0.01, and if you divide this by 2, that's going to be 0.005, and we are going to have that one in the left side and the right side. Okay, so here we are going to have 0.05, and also here we are going to have 0.05. So this one is going to be 0.99, right? Now that's our diagram, and the next step is find the critical values, T distribution table. So we are going to use this one. But in order to use this one, we have to find the degree freedom. Degree freedom can be calculated using this formula. Degree freedom is equal to n minus 1. N is number of samples, that is 35. 35 minus 1, then that's going to give us 34. And the alpha value in each tail, right? So we have to look at the alpha value in a tail. So that is 0.05. And here we have the T distribution table. 0.05 is here, and then 34 is in the bottom right here. And if we connect these two, that's going to give us this point, 2.728. And in the left hand side, it's always negative, so this one is going to be negative 2.728, and this is going to be positive 2.728, and this is our critical values. Okay, now we found out our critical values. The next step is find the test statistic. Okay, so we have to find the t value. Now in order to do this one, I had to use this calculator. Okay, go to this, click the statistics, and then go to the test, and then t-test, and then enter. So here we have mean. Yeah, select the stats. After that we have to go down, and here the mean value we have is 59. That's already here, and x bar is 63. So I have to change this one into 63, and the standard deviation is 2.3. So this is going to be 2.3, and n value is 35. This is 35, and this is not equal to, we are dealing with not equal to, enter, and then calculate, and here we are getting 10.28, and if we round this one like 288, so that's going to be 10.29. Okay, let's go ahead and write that one right here. Oh my, okay, here we go. 10.29. T value is equal to 10.29. Okay, now 10.29, you have to look at the critical values here, negative 2.728, and if we get value less than that, it's fall behind, and if we get value greater than this 2.78, it's fall under this tail, and if we get values in between this negative 2 and this one, that's going to be in the middle. And here if you see this t value, this is 10.29. This is definitely this side, right? So this is falling under this tail. So this is falling under tail. So here they're saying if the test statistics falls in tail, reject h0. So in the conclusion, so let's write down the conclusion right here. Conclusion. So we are, this one is falling under this right hand side tail. So we are going to reject h0. Reject h0. So if we reject h0, we have to accept h1. Accept h1, and the claim falls under the h1, right? Because we know that this is not equal to is only for h1. Okay, so we've already found out that claims fall under this h1. So we are accepting h1, so we are going to accept the claim. Accept the claim, and that's going to be the final conclusion. I hope this helps. Thanks for watching.